Okay, so here's the question that I want us to look at for today. Okay, it's on Newton-Raphson method as well as second method. So we're going to try using both methods, okay, to solve the problem. Okay, remember last time we looked at Newton's-Raphson method. Okay, we solved one example, of course, and we saw how Newton's-Raphson method works and its rate of convergence. We concluded that, okay, Newton's-Raphson method converges faster as compared to fixed point iteration method. Okay, so today we're still focusing on the same method, which is the Newton's-Raphson method. We're going to solve the problems here. So maybe looking at the time, because as I said that these methods require a lot of time. Okay, so looking at the time we have, I don't know if we're going to solve everything or can just solve two or can just solve one. We'll see. Okay, so let's look at the question. So the question reads, use the Newton-Raphson method and the second method to find solutions accurate to within 10 to the power negative 4 for each of the following problems, starting with a given x naught. Okay, so our first focus will be on the Newton-Raphson method. Next, to look at the second method to solve the same problem when we use second method. Okay, so first of all, let's focus on Newton-Raphson method. Okay, so look at the condition given to us. We say that, oh, we have to find the solution accurate within 10 to the power negative 4. So this means that we have to be checking that error every time we do the iteration, just like we've been doing before. Okay, so of course, this question could also be asked like to use second method to find solutions to 4 significant figures, because so to 4 decimal places. Okay, 10 to the power negative 4, that is the notation for decimal places, not so 10 to the power negative something, right? So it could have been asked, oh, find the solution to 4 decimal places. Okay, so you know what to do if you say 4 decimal places, and you know what to do if you say 5 significant figures. Okay, all right, so let's start. So we're going to start with the Newton's-Raphson method. So we start with Newton's-Raphson method. Okay, Raphson method, that's what we're going to start with first. Okay, just a reminder that this is a formula that we apply, of course. X of n is equal to x of n minus 1 minus, sometimes you can see p, right? P of n is equal to p of n minus 1, just the same notation. Okay, f of x n minus 1 divided by the derivative at that point, right? So f of prime x of n minus 1. Okay, this is a formula for what? For Newton's-Raphson method. Okay, so we start with question 1, right? So question 1, we are given x cubed plus 3x squared minus 1 equal to 0, right? Okay, and we're given the initial condition. Okay, so the initial condition is x naught equal to negative 3. Okay, so every time you're using Newton's-Raphson method, make sure that you have a function as well as its derivative. Okay, so let's find the derivative of this function first. Okay, so f prime of x. Okay, so say f prime of x and x naught. Okay, this is equal to 3x squared plus 6x. Okay, so this is a derivative, isn't it? Now let us find this, right? So we start for n equal to 1, right? So for n equal to 1 means that we're going to find x1, right? So this would be x1 equal to, this would be what? x1 minus 1, this would be x naught. Okay, so end up having x naught here minus f of o, this would be f of x naught, of course, because n is equal to 1. So this will be f of x naught divide by f prime of x naught, right? Okay, so x naught, of course, is given to us, which is negative 3. So we have to find f prime of x naught, okay, f of x naught as well as f prime of x naught. So let's find f of x naught, okay. So f of x naught is equal to f of -3, right? Okay. So f of -3 is equal to what? We substitute in the function, right? Okay. The function x cubed plus 3x squared minus 1, right? So substitute -3. So we have -3 to the power 3 plus 3 -3 squared minus 1, right? So -3 to the power 3, that is -27. This, oh, that's, yes, -27, and this positive 27. They cancel out each other, just end up having -1, right? Okay. So that is f of x naught. And then also let's get f prime of x naught. So f prime of x naught, this is the f prime of -3. So we have 3 times -3 squared plus 6 -3. Okay, and what do you get here? So this gives me +9, right? Okay, so some should try to check, confirm if that is true. So I'm getting +9, okay? All right, so now we go back and substitute in our formula, right? So we're going to find x1, isn't it? Okay, so x1 will be equal to this expression, right? Okay, so meaning that our x1 therefore, okay, will be equal to x naught. Okay, so what is our x naught? Our x naught is equal to -3 minus f of x naught, which is -1, divided by 9. So this is -3. So this is -1 times negative here, +1 over 9. So this gives me about -2.888, some 8 repeated, not so. Okay. So this is my x1, isn't it? So remember that we have to find the solution, okay, accurate within 10 power -4. So now we have to pause and check the condition. Okay, so we have to check the condition. So the condition is that the next value minus the previous value of x divided by the next value that we found, or the present value. Of course, we're just interested in the absolute value, okay? We're not interested in the sign. This should be less or equal to 10 to the power -4. That is what the condition states, okay? So if we substitute these values, so the present value is xn, in this case now is -2.8 repeated, okay? 2.8 repeated, and then minus the previous value, which is -3. So this will be +3, okay? Divided by the present value, which is 2.8 repeated, right? 2.888 repeated. But of course, just interested in the value itself. We don't interest in the sign, okay? So what do you get if you check that, right? Okay, so let's see. So I'm getting about 0.038, but someone also should check and confirm if this is true. For 6,
It
okay,
is.
and this is it. Thank you. And this is greater than 10 to the power -4. Okay, so we still have more work to do, not so. Okay, so let's get x2 now. So I'm going to say now for n equal to 2. So this now the second iteration. For n equal to 2, you notice that we're going to have x2 equal to x1, f of x1, f prime of x1 also. Okay. So for n equal to 2, we're going to get x2 equal to x1, the previous approximation, minus f prime of f of x1. Okay. Just this. Okay. Minus f of x1 divided by f prime of x1. So we have to find f of x1 as well as f prime of x1, right? So what is f of x1? Okay, f of x1, this is equal to, okay, so in the function f of x, substitute x1, and our x1 is negative 2.88 repeated, okay? So we substitute that, we're going to have negative 2.8888 repeated. You can put how many 8s you want, okay, to the power 3, plus 3, negative 2.88888 repeated, okay, squared minus 1, right? So please kindly confirm what you people get this. I'm getting about 7.70, but should confirm if it is true. 370, 370, 370, somewhere there, depending on how many eggs you have put, okay? Yeah, so but it should be that range. And then also let's get the derivative, f prime of x1. So the derivative of that is, remember that is 3x squared. We got the derivative. Where is it? This is a derivative, right? 3x squared plus 6x. So substitute the value of x, which is x1. So 3 negative 2.888 repeated, okay, to the power 3, plus 6, okay, negative 2.8888 repeated, okay, and then how much? Oh, sorry, f of x1, this is not what you get. Okay, I hope you people are checking this. This is not what you get for f of x1. This should be negative 0 point something, right? Did someone
0.0 something.
0.07, right?
Yes,
Is it?
that one.
Yes. And you're quiet. You're just watching me messing up. Okay.
No, I was calculating. I was
Okay.
trying to see.
All right, right. But this one I just did the opposite, right? Okay. Because I had some value that I had to punch at some point. 70, 370, 70, like this. Try to confirm if the derivative gives you this value. Okay. Try to confirm if that is true. Okay. Now we go ahead and substitute. So f prime, f of x1 gives us that, f prime of x1 gives us that, okay? So now let's substitute, we find x2. So x2 is equal to x1, remember that x1 was negative 2.888 repeated, minus f of x1, this is the negative 0.07230233196 divided by this, right, which is 7.70 370 somewhere there. Okay, so if you check that one, so x2, you should get something approximately equal to negative 2.87. Please verify if this is true. Okay, 9450 95. Okay, so there will be a small variation depending on how many decimal places you've
I'm
gotten.
not getting what you've gotten on the f prime of x1. I'm
What
getting like 89.
are you sure?
With my calculator.
Yes, so we're getting 89. Check properly. Try to check. Okay. So okay, that's 95798. Okay, and we check the condition. So the condition now to be x2 minus x1 divided by x2, right? Let's check, okay, how far we've gone. So this is equal to, so our x2 now is at value is negative 2.87, 9450 798. Okay, our x1 was negative 2.88. This is the one we put here to check the condition. So have you confirmed? Or there's still a problem somewhere?
I'm still getting that. Maybe it's my calculator.
How? Okay, are you putting a 3 here front?
Yes.
And then 2.88
With
something
3, 8, yes. That's what you put.
and then 6,
Yes.
negative 2 something again. How is that possible?
Maybe try with your calculator.
Okay, let me try it again.
Maybe it's just me.
In fact, it's the derivative that's wrong.
Oh yeah, thank you. So thank you for that observation. The derivative should be squared here, not cubed. Okay, remember the derivatives.
Oh, okay. That's why.
Yes. It's actually the
Let me try.
derivative. Yeah, thank you. So this should be squared, okay, not cubed. Okay, let's move then. Okay, so let us move. So in the denominator here we have what? We have negative 2.87, but just tracing the absolute of that. Okay, absolute value. So how much is that when you check that condition? Okay, I'm getting about 0.003. Okay, 278. And of course, this is still greater than 10 to the power negative 4, right? So I can stop here. Okay, so this is still greater than 10 to the power negative 4. So for n equal to 3, let's check for n equal to 3 now. So we're going to have x3. So x3 will be equal to x2 minus f of x2 divided by f prime of x2. Have you confirmed now you're getting the same value?
Yes, it is.
Okay. All right. So now we have to find f of x2. Okay, so let's get f of x2. So f of x2 would be equal to, so our x2 was what? Negative 2.87. Okay, 2.87, 9450 somewhere there, and then 95, 798, the power 3, plus 3, okay, negative 2.87, okay, you can finish there, squared minus 1, right? And let's see what we get here. Okay, so this is a negative 0.000, okay, 499. Check. Okay, don't just be content with the value. Okay, 92 and then 27. Okay, so this is f of x2, and then also let's substitute in its derivative f prime of x2. So this is a, remember the derivative is 3 here, then negative 2.87945. Can finish the values there. The power 2, okay, plus 6, negative 2.87945. Can finish the values there. Okay, so its derivative is giving me how much? So I'm getting about 7.5, but you can also check this. Okay, 7.59, 700. Okay, 771036. Okay, so this is the derivative. Now let's apply this formula here to find x3. So x3 is equal to our x2. What was our x2? Was negative 2.87. Okay. Okay, negative 2.87 9450, 95798. Okay, so this is it. And then minus f of x2. Our f of x2 is this guy negative here. Is negative 0.000. Kalu, have you checked? Have you confirmed?
Yes.
Okay. 227 divided by 7.59 700 771036. Okay, so if you check that one, the value is about our x3 is about 2.87. Okay, it's negative, of course. Okay, negative 2.87938. Okay, 524 892. Okay, somewhere there. So this is it, our x3. Now again, since we have x3, we can now check the condition as well. So we're going to say x3 minus x2 divided by x3. So let's check. Okay, so our x3 is at the value here, negative 2.8793852. Okay, 892 minus our x2. Our x2 is negative, of course, so this is the plus 2.87. Okay, 94, that is our x2. 50 95798 divided by the same x3. Okay, of course, we just need the absolute value of that. Negative 2.87938524 and if you check this one, okay, so the error is about 0.0000. Okay, 0.00. 4 zeros, of course, 228, right? 2282. So you see this is value now is less than 10 to the power negative 4. Okay, so this is the final iteration. So it means that after approximating to the accuracy of the 10 to the power negative 4, our value, which is the root, so the root, okay, of our equation okay is, which is x3, which is a negative 2.87938524892. Okay, so this is our solution. Anyone with a question? We have about less than 10 minutes left. Anyone with a question, please? Any question?
So, hello.
Yes, please.
So this method has no conditions.
What conditions do you mean?
Like the previous ones, it has to be continuous. And
No, this one has no condition. The only condition which is there is that the derivative at a point xn, this derivative we must never be equal to 0. That's one condition. Because once this guy is equal to 0, then everything comes a mess. Because you have a fraction which is over 0, a number over 0, and that is not allowed in math. Okay, that's one condition. So the condition is that f prime of xn minus 1 must never be equal to 0. That's one condition that you have. Eh?
all right, okay.
Yes, yes. Okay, so let's have another session where we're going to solve the same problem using second method. Okay, since the time is almost up, so let's have another session. We're going to solve the same problem using a second method. Okay, so let's log out, come back, and continue using second method. Okay.